Yes, good morning. Welcome to the flight dynamics class. Today we are going to see about the stick force gradient in unaccelerated flight. In last class we discussed about the free condition, neutral point. It is an unaccelerated condition. So here we are going to find out what is the stick force is required to move the elevator. So let us take this stick. This is a control stick. So where we can have the reflection of the elevator. So here we have the reflection of the elevator. So here we have the directions, we have the pivot. Right? So if we apply the stick force, positive force, it will produce the hinge moment. It will produce the hinge moment. So here we are going to find what is the work done is happening. So work done on top of the stick, this question is equal to work done at elevator to deflect. So work done on top of the stick will be get deflected. So it will get deflected. So we will get deflection of stick, right? Is equal to work done at the elevator to deflect, right? So here hinge mode will get produced. So we will here have the deflection of elevator. Here we have the deflection of stick. So work done will be half times stick force, length of the stick, deflection of stick. That is a deflection of stick is equal to work done produced in hinge moment into deflection of elevator. Now from this we can get the what is deflection of elevator or what is the deflection of stick force. So now we can get the actual value from the work done. We need is how much force is required to deflect the elevator. So for that the stick force will be F is equal to this half we can cancel. Stick force will be hinge moment, deflection of elevator, length of the stick, deflection of the stick. So this term will get gearing force. This is the gearing force. G is equal to deflection of elevator, length of the stick, deflection of the stick. The force will be in the negative direction to produce positive deflection. So we will get minus gearing force into hinge moment. This equation can be rewritten like this. Now the hinge moment of the elevator, hinge moment of this elevator is purely depends upon dynamic pressure of rho v equal square over the control surface and to what is the wing surface, what is the car, what is the tail volume ratio, right? And how much is produced the hinge moment coefficient. That is the coefficient is not due to deflection of, you call as deflection of elevator. So now we can rewrite this as rho v to square SW C CH deflection of elevator into tail ratio. Now the force equation will be minus G. This will write as Q, dimension Q, as W car CH deflection of elevator into tail ratio. This is the stick. Now where the hinge moment coefficient, that is CH elevator deflection is equal to 0 hinge moment coefficient plus hinge moment coefficient due to deflection of control surface due to angular attack plus hinge moment coefficient deflection of elevator due to deflection of elevator plus hinge moment coefficient due to trim tab due to deflection of trim tab. So these are the hinge moment coefficient we need to substitute here for this CH delta now. So we'll get the final force required value, right? So F is equal to minus G Q SW, that is mean surface, star, tail efficiency, then CH naught, CH alpha, CH deflection of elevator, due to deflection of elevator, coefficient of trim tab, due to deflection of trim tab. So now we are going to add one more term for alpha. Alpha we already know. Alpha S, alpha W minus downward effect minus incident angle of bending plus incident angle of bending. This we can substitute here. This we can rewrite as 1 minus d sin by dc. This we can write as so now one more term is there, the deflection of elevator. So that we can write as deflection of elevator is equal to 1 minus. Now the deflection of elevator can be as 0 deflection of elevator minus dcm by dcl, that is in fixed condition. That time you get cl by cm deflection of elevator. So now we can substitute all those things like alpha value, deflection of elevator value. Finally we will rearrange this slip force. Finally, we rearrange this equation by substituting the alpha and deflection of elevator. We are getting half rho v square k. A is the bearing force in surface area, hard length into tail efficiency, and Ka will be coefficient of inbound coefficient with respect to this angle of attack coefficient. This is the angle of attack, zero angle of attack, wing incident, tail incident. This is the deflection of elevator. All the things are incorporated here and we get to final slip force equation, slip force gradient equation for unaccelerated flight.